Hey guys, I wanted to make a video to show you how to do some of these problems here. Problems 1, 2, and 5 shouldn't be that hard. They're pretty much just straight up, excuse me, either find the potential energy or find the kinetic energy. But problems 3 and 4 are a little bit harder because you got to use conservation of energy concepts in order to solve them. So let's start with number 3 right here. In that problem, they say that there is a pool ball shot on top of a table here, and it's moving and it flies off the table, and then it comes and it gets close to the ground, and it tells you how fast it's going on the ground. And they want to know how fast it was going up on top of here. So the thing with all of these types of problems that you got to keep in mind is that the energy in the beginning is equal to the energy in the end. So I'm going to write it like this. Mechanical energy initially is equal to the mechanical energy finally. And so the total amount of mechanical energy won't change. Remember that mechanical energy is the total kinetic and potential. So another way we could write this is the gravitational potential energy initially plus the kinetic energy initially is equal to the gravitational potential energy finally plus the kinetic energy finally. So, and then sometimes I don't write this full step out. I look at the problem and sort of decide what they have. So for example, in this one, the ball's moving up on top of the table, so it's got initial kinetic energy, and it's up on top of a table. It has a height, so it has initial gravitational potential energy. It's moving in the end, so it's got kinetic energy in the final position. Let me even write a little F right here for final and a little I up here for initial. But it's on the ground here in the end, so it doesn't have any final gravitational potential energy, so we can cross that out there and get rid of it. So the next line that we can write is fill in for each one of these equations. So mass times gravity times our height, and sometimes the books will write this as h for height, same thing. Put a little I there for initial, plus 1/2 times mass times initial velocity squared is going to equal, this is gone, so we'll substitute in for this, 1/2 times mass times final velocity squared. Now, one thing that happens here in this problem, which is good, makes things a little bit easier, is that there's a mass here, a mass here, and a mass here. There's a mass in every term, so those masses actually cancel out. We don't need them. If they gave us the mass, you could plug it in. It wouldn't make the equation wrong, but you don't need it. So sometimes they don't even give you the mass, and then people are like, what do? I don't have the mass, I can't solve it, but you don't need it, it cancels out. So now that we have all of this, we can start to plug in our numbers. So gravity, acceleration due to gravity is 10. Our initial height in the problem, what did they say it was? It was 0.68 meters. So our initial height there is 0.68 plus 1/2. Our initial velocity is what we're looking for. And then our final velocity, they told us that it hits the ground going 6 meters per second. And so now it's just algebra. We can solve this. 10 times 0.68 will give us 6.8 plus 1/2 times initial velocity squared. And then over here, 6 squared is 36. Half of that is 18. Subtract this term over to the other side. We get 1/2 is initial velocity squared. 18 minus 6.8 is 11.2. Multiply 2 by each side to get rid of this. So initial velocity squared, that will go away. This will become 22.4. And then finally, take the square root of each side to get rid of that. So the initial velocity will equal the square root of 22.4, which is about 4.7 meters per second.